another simply supported beam of length L, but here loading is concentrated load at midpoint. Concentrated load at midpoint. So our first task is to determine the reaction forces. What are the reaction forces? Here it is RA and here it is RB. And this is the force. So by applying force equation, we will get RA plus RB is equal to P. And if this length is L, by moment equation, we will get RB into L minus P into L by 2 is 0. This length is L by 2. So RB is P by 2. Similarly, RA is also P by 2. So both the forces are P by 2. So here this reaction is P by 2 and this reaction is also P by 2. Now how to get bending moment and shear force diagram? Now here we have to take two sections. Why? Because up to A to C, that is within this range, x greater than 0 less than L by 2, there is no discontinuity of force. So we'll take a section once here, but there is a discontinuity of force due to this concentrated load P. So we have to take another section whose where range of x will be x greater than L by 2 less than L. So here we have to take two sections to complete the shear force and bending moment diagram. So first let us take this section, that is, say if this is D and this point is E. So first let us draw the free body diagram of AD. Here reaction force is P by 2. This is point A. This is D. Shear force is Bx and bending moment is Mx. So from this, what we will get if we apply the force equation? Vx is P by 2 and Mx is P by 2x. Now let us draw the other section. Other section is, that is, this is for this range x greater than 0 less than L by 2. Now let us draw the free body diagram for AE. Let us draw AE. This is A, this is E. The reaction force here, that is P by 2 here at L by 2. P force is applied. This is L by 2 distance. This is x. This is x. Sorry, this is also x. This distance was x. Now shear force and bending moment at this right hand face is Px, and here bending moment is Mx. Now what is Vx? Vx is P minus P by 2. P minus P by 2. Sorry, I'm extremely sorry here. Or let me write down it once again. Vx plus P minus P by 2 is 0. That is, Vx is minus P by 2. What about Mx? That is Mx plus P into distance is x minus L by 2. X minus L by 2. And this force is P by 2. that is minus opposite sense of moment. I am taking moment about point E. So minus p by 2 minus p by 2 into x is 0. That is mx becomes p by 2x minus px plus pl by 2. That is mx is pl by 2 minus px by 2. So this is the, or you can write, yes, that is over. So let us come to the next page. That is, we got two set of equation. Vx is p by 2 and mx is p by 2x. This is for x greater than 0 less than L by 2. For x greater than L by 2 less than L, what is the value? Vx is minus p by 2. Vx is minus p by 2 and mx is what? Mx is pl by 2 minus px by 2. pl by 2 minus px by 2. So these are two set of equation. Now let us draw the shear force and bending moment diagram for this beam. So this is P, this is A, this is P, this is a pin joint, and there is a roller joint. Now first, let us draw the shear force diagram. Shear force. And we know that both the reactions are P by 2 and P by 2. So shear force, what about shear force? Vx is P by 2. Vx is P by 2 up to L by 2. So this is constant P by 2 or plus P by 2. Then for this portion x less than L by 2, x greater than L by 2 and less than L, that is P is minus P by 2. Constant minus P by 2. So this is the shear force diagram. This is the shear force diagram. And we can see at L by 2, at x equal to L by 2, there is an abrupt change in shear force diagram. Shear force suddenly drop by an amount P. Next is bending moment diagram. Bending moment diagram. Mx is P by 2. Mx is P by 2. So up to L by 2. So at L by 2, the value of Mx is PL square by 4. Sorry, the value will be at x equal to L by 2, P by 2 into L by 2. That is, sorry, PL by 4. So this value is PL by 4. And this is the equation of straight line. So here PL by 4. The value is PL by 4. Next, at here at x equal to L by 2, what is the value? PL by 2 minus P by 2 into L by 2. That is PL by 2 minus PL by 4. That is PL by 4. And at x equal to L, what is the value? That is 0. Mx is 0 for this portion. So that also varies like this. So this is the bending moment diagram and this is the shear force diagram.